Proofs. The pieces that make up a proof and explain how they work. We'll start with some easy algebra proofs, and from there geometry proofs will be no problem. So what is a proof? It's the process of demonstrating your steps of math in order to show that a conclusion is true. So the first column will be those steps, either algebra or geometric deductive reasoning, leading to a conclusion. Really was proving your answers. We're just going to do some extra writing here to justify each step. Let's name these types of justifications. Given information, what do we start with? Definitions, there are a lot of them. We can refer to the back of the book or notes until we start to commit them to memory. Properties, we're going to go through some algebra properties you should already know. There will be quite a few new geometric properties as well. Postulates, these are things we don't need to prove. We accept as true without proof. We have quite a few already. And once we get into proofs, we will be proving theorems. And once we do that, we then have more justifications we can use in this column. Alright, here's a quick review of properties from algebra. Given that we do have an equation where left side equals right side, in this case we're calling it A equals B. Addition property of equality, I can add the same thing to both sides of an equation. Subtraction property of equality, I can subtract the same thing from both sides of an equation. Multiplication property of equality, I can multiply both sides of an equation by the same value. Division property of equality says I can divide both sides of an equation by the same value as long as that denominator is not zero. Reflexive property. Reflexive property, anything equals itself. The symmetric property states that I can switch an equation around. If A equals B, then B equals A. The transitive property follows the same pattern as our syllogistic logic. There are 3 steps, and transitive property says if A equals B and B equals C, then A equals C. The substitution property says if 2 values are equal, I can exchange one for the other and maintain the same equation. And the last justification step we should know about is the one called simplify. Anytime you're working with an equation and you combine like terms on one side of the equation or reduce a fraction on another side, etc., we just call that simplify. Let's do an algebra proof. This is our given information, or our given equation. 3 was distributed. Distributive property. Later this will be abbreviated. Combining like terms, simplify. Subtract 3n from both sides. Subtraction property of equality. Divide both sides by 2, division property of equality. Box my answer. So again, what we've done is proven our conclusion. Last proof. This is our given equation. Rearrange my grouping of an addition problem, associative property of addition. Combining like terms, simplify. Subtracting 2n from both sides, subtraction property of equality. Add 6 to both sides, addition property of equality. Divide both sides by 2, division property of equality. Thanks for watching. Keep practicing.